All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still doing our human emotions detection module. Let's have a look at what we went over today. Yesterday, if you recall, we started the VegNet module, and today we're going to pick up where we left off. Today, we're going to be seeing why it's better to work with smaller filters compared to working with larger filters. Let's consider the following examples. We'll start with the 5 by 5 filter. We'll have a kernel size of 5 and an input size of 10, no padding, a dilation of 1, and a stride of 1. I'm pretty sure you remember we did these in the past when we drew out our boxes and our grids hand by hand. I'm not going to do that here. You just have to use your imagination. Let's say we have a filter of 5 by 5 and we have a grid of 10. So you can picture our 5 by 5 filter and our grid of 10. That's going to be a 10 by 10 grid. So with that being said, we would be able to get an output of 6 by 6 if we have a stride of 1. So you have to imagine our 5 by 5 filter moving along our 10 by 10 grid, one stride at a time until it can't. So you can move from left to right, one stride at a time, and then we move from top to bottom, one stride at a time. That it ultimately get us an output of 6 by 6. The next example will have all the same dimensions. The only difference is we'll have a filter of 3 by 3. Now this will get us an output of 8 by 8. So like I said, we're going to move our 3 by 3 filter across our 10 by 10 grid, one stride at a time from left to right, and then from top to bottom. With the 5 by 5, we will have a total of 25 parameters. So we're going to do 5 times 5. And then with the 3 by 3 filters, we will have a total of 18 parameters because each filter alone will have 9 parameters, 3 times 9, and then we combined, we will have 18 total parameters. This will give us two output layers of 8 by 8. I'm not sure if I specified it, but we have two small 3 by 3 filters, and we have one regular size 5 by 5 filter. So that's why we have the 3 there. We have a 3 by 3, and then we have 3 by 3 again. So that's going to get us 9 filters for the first one, 9 filters for the second one. When combined, we have 18 total filters or 18 parameters because of each filters. And then the output will be 8 by 8 for each. So let's say we had again a 10 by 10 grid and we have a 3 by 3 filter. We would move that filter across that 10 by 10 grid. We can move it 8 times left, and then we can have it. We can move it 8 times to the bottom if we started from the top. So that's why the 8 by 8. Now, because of this, it will be better to use the small filters as opposed to using a single large filter. We have a higher degree of learning capabilities with the outputs produced by the 3 by 3 filters. As you can see here, we would have 8 by 8 as opposed to the 6 by 6 with the 5 by 5. So the 5 by 5 will give us 6 by 6 output, but the 3 by 3 will give us 8 by 8. So we have a higher degree of coming across information with the 3 by 3 filter. A single 5 by 5 filter will have a single output of 6 by 6, whereas the two 3 by 3 filters will have two outputs of 8 by 8, thus giving us a higher learning capability percentage, allowing us to capture more complex information from the inputs, like I just stated. Now, also, even though there are two filters of 3 by 3, it would still be cheaper or cost efficient to run these two filters as opposed to the 5 by 5. This is because there are fewer parameters to work through. One 3 by 3 filter will have 9 parameters, and combined they will have 18 parameters. This is still less than the 25 parameters of the 5 by 5 filter. So overall, we see that it's better to use a small It's better to use the small filters with these curved layers as opposed to the larger filters. And basically, that's what we went over all morning, just going over how we will be more cost effective and more learning capable using smaller filters as opposed to larger filters inside of our carve nets. That was actually the end of the module for the VegNet, and we are going to start a new module tomorrow, the ResNet. I'm not sure exactly what this is. I'm not sure if there's going to be more documentation or we're actually going to get back to coding anytime soon. But yeah, so that's where we are, and we will keep moving forward. Of course, I will keep you posted every step of the way. But for now, it's the Python Poppy. You guys stay Gucci.